So hello everyone. So in this class, I am going to discuss about what is the potential energy of system of charges. So on this topic, so three topics are there: potential energy of the two charges in the absence of electric field, and potential energy of the three charges in the absence of electric field, and potential of the two charges in the presence of electric field. Okay. So now understand what is the meaning of potential energy of system of charges. Okay. See, potential energy of the system of charges means it is the total amount of work done in bringing the charges from the infinity to the given positions. Okay. So this work done only stored as potential energy inside the charges. Okay. So now, so this derivation, potential energy of the two charges in the absence of electric field. See, suppose if I bring the charge q1 from the infinity to the point here. Okay, so there is no work done is needed. Why? Because there is no interaction of other charges. So simple ಆಗಿ ಹೇಳಬೇಕಂದ್ರೆ ಈ ಚಾರ್ಜ್ ನ ನಾವು ಇನ್ಫಿನಿಟಿ ಇಂದ ಈ ಪಾಯಿಂಟ್ ಗೆ ತರ್ತಾ ಇದೀನಿ, ಇಲ್ಲಿ ಜಗಳ ಆಡೋರು ಯಾರು ಇಲ್ಲ, ಆರಾಮಾಗಿ ತಂದ್ಬಿಡಬಹುದು. ಓಕೆ, ಸೊ ಅಗೈನ್ suppose if I want the charge q2 to bring from the infinity to this point, I need to do work done. Why? So the interaction of q1 is there. I need to overcome the potential of charge q1. ಓಕೆ, ಸೊ ಇದ್ರ ಜೊತೆಗೆ ಜಗಳ ಆಡ್ಬೇಕು ನಾನು. ಸೊ ಆಗ ವರ್ಕ್ ಡನ್ ಮಾಡ್ಬೋದು. ಓಕೆನಾ? ಸೊ ಈಗ ಇದ್ರದ್ದು ಪೊಸಿಷನ್ ವೆಕ್ಟರ್ r12. ಓಕೆ, ಸೊ w2. ಸೊ w2 ಫಾರ್ಮುಲಾ ಏನ್ ಬರುತ್ತೆ ಇಲ್ಲಿ? ಸೊ ಪೊಟೆನ್ಷಿಯಲ್ ಫಾರ್ಮುಲಾ v is equal to w by q. ವರ್ಕ್ ಡನ್ ಬಿಕಮ್ಸ್ ಸೊ ಪೊಟೆನ್ಷಿಯಲ್ ಇಂಟು ಚಾರ್ಜ್. ಯಾವ ಚಾರ್ಜ್ ನ ತಗೊಂಡ್ ಬರ್ತಾ ಇದ್ರಿ ಆ ಚಾರ್ಜ್ ನ ಮೆನ್ಷನ್ ಮಾಡಬೇಕು. ಯಾವ್ದನ್ನ ತಗೊಂಡ್ ಬರ್ತಾ ಇರೋದು q2. ಅಂಡ್ ಪೊಟೆನ್ಷಿಯಲ್ ಯಾವ್ದ್ರದ್ದು ಓವರ್ಕಮ್ ಮಾಡಬೇಕು? ಐ ನೀಡ್ ಟು ಓವರ್ಕಮ್ ದ ಪೊಟೆನ್ಷಿಯಲ್ V1. Okay, so now, so W2 is equal to, what is potential formula? V is equal to 1 by 4 pi epsilon Q by R. But ಇಲ್ಲಿ Q is Q1 and its position vector is R12 into Q2. Okay, so now equation 1 ಅನ್ಕೊಳ್ಳಿ, call this as equation 2. Now this work done only will store it as potential energy inside the charges. So total potential U becomes W1 plus W2. U is equal to W1 is 0 and W2 is 1 divided by 4 pi epsilon Q1 Q2 divided by R12. Okay, so this is the final expression for the potential energy of the two charges in the absence of electric field. Okay, so similarly the another case, potential energy of the three charges in the absence of electric field. Okay, so again the same condition only. In order to bring the charge q1 from the infinity to this point, the work done is 0. Why work done is 0? Because there is no interaction of any other charges. So q1 ಜೊತೆ ಜಗಳ ಆಡೋರು ಯಾರು ಇಲ್ಲ, ಆರಾಮಾಗಿ ತಂದ್ಬಿಡ್ಬೋದು. ಓಕೆನಾ? So w1 is equal to 0. Call this position as A. See, suppose if I want to bring the charge q2 from the infinity, so obviously I need to do certain amount of work done. Okay, so in order to overcome the potential of q1. Okay, so idradu potential r12. Okay na? So already previously ನಾವು w2 already ಕಂಡುಹಿಡಿದಿದ್ರಲ್ವಾ. so two charges ಆಗೋಯ್ತು ಇವಾಗ. w2 is equal to 1 divided by 4 pi epsilon q1 q2 divided by r12. Okay, call this as equation 1, call this as equation 2. Okay, see now, see suppose if I want the charge q3 to bring from infinity to this point, I need to overcome the potential of charge q1 also and charge q2 also. Okay, so charge q3 ನ ನಾನು ಇನ್ಫಿನಿಟಿ ಇಂದ ತಗೊಂಡ್ ಬರಬೇಕಾದ್ರೆ q1 ದು ಪೊಟೆನ್ಷಿಯಲ್ ಓವರ್ಕಮ್ ಮಾಡಬೇಕು, q2 ದು ಪೊಟೆನ್ಷಿಯಲ್, ಸೊ q2 ಪೊಟೆನ್ಷಿಯಲ್ ಕೂಡ ಓವರ್ಕಮ್ ಮಾಡಬೇಕು. ಓಕೆ, ಸಿಂಪಲ್ ಆಗಿ ಹೇಳ್ಬೇಕಂದ್ರೆ ಸೊ q3 q1 ಜೊತೆಗೆ ಜಗಳ ಆಡಬೇಕು, q2 ಜೊತೆಗೆ ಜಗಳ ಆಡಬೇಕು. ಓಕೆನಾ? ಸೊ ಈಗ ದಿಸ್ ಪೊಸಿಷನ್ ವೆಕ್ಟರ್ is r13 and its position vector is r23. Okay, so now w3 becomes so potential into charge. So potential charge ತಗೊಂಬರ್ತಾರ ಚಾರ್ಜ್ ಯಾವುದು? q3. so potential, we will get two potential, one is due to the q1 also and q2 also. so w3 is equal to potential due to the q1 1 divided by 4 pi epsilon naught q1 divided by r13 its position vector plus 1 divided by 4 pi epsilon naught. So q2 divided by its position vector is r23. Okay, so multiplied by so charge, which is a charge q3. Now w3 is equal to 1 divided by 4 pi epsilon q1 multiplied q3 for both the terms. So q1 q3 divided by r13 plus 1 divided by 4 pi epsilon naught q2 q3 divided by r23. Okay, so this work done only will store it as potential energy inside the charges. Now add all the potentials. So U is equal to W1 plus W2 plus W3. Okay, so U is equal to W1 is 0 and W2. So W2 is 1 divided by 4 pi epsilon naught Q1 Q2 divided by R12 plus W3 is 1 divided by 4 pi epsilon naught Q1 Q3 divided by R13 plus Q2 Q3 divided by R23. Okay, so this is the final expression for the system of three charges in the absence of electric field. Okay, so similarly, so opposite case in the presence of electric field. So in the presence of electric field ಅಂತಂದ್ರೆ ನಾವು ವರ್ಕ್ ಡನ್ ಮಾಡಲೇಬೇಕಾಗುತ್ತೆ. ಓಕೆನಾ? ಸೊ ಈಗ ನೋಡಿ, so potential is the two charges in the presence of electric field. See, suppose electric field already ಇದೆ, ಇಲ್ಲಿ electric field ಇದೆ. ಓಕೆನಾ? So see, suppose if I want to bring the charge from the infinity to this point, I need to do work done. Okay, why? Because already electric field is there. Okay, so now if I want to bring the charge q2 from the infinity, obviously I need to do some amount of work done. Why? Because due to the interaction of the charge q1, or in order to work on the potential of the charge q1. Okay, now so its position vector is r12. Okay, so now in the presence of electric field, formula is potential energy is, so potential energy of charge q1 at A plus potential energy of charge q2 at B plus potential energy of two charges in the absence of electric field. So presence ಅಂದ್ಬಿಟ್ಟು absence ಆಗಿ ಬರೀತೀನಿ ಅಂತ ಕನ್ಫ್ಯೂಷನ್ ಆಗಬೇಡಿ. ಇದು ಇನಿಷಿಯಲ್ ಕಂಡೀಷನ್, ಇನ್ ದ absence of electric field ಮೂರು ಕೂಡ ಆಡ್ ಮಾಡಬೇಕು. See, potential energy is equal to potential energy of the charge q1 ಏನು ಬರುತ್ತೆ, so v1 into q1. why? Because ಫಾರ್ಮುಲಾ ಗೊತ್ತಿದೆ ಅಲ್ವಾ ನಿಮಗೆ. so v is equal to w divided by q. okay, so w becomes v into q. for q1 charge v1 into q1, for q2 charge v2 into q2 plus potential energy of the two charges in the absence of electric field ಅಂತಂದ್ರೆ, so 1 divided by 4 pi epsilon naught q1 q2 divided by r12. ಓಕೆನಾ? ಸೊ ಅರ್ಥ ಆಯ್ತಾ ಮೂರು ಕೇಸು ಕೂಡ. ಸೊ ಓಕೆ, ಥ್ಯಾಂಕ್ ಯು ಫಾರ್ ವಾಚಿಂಗ್.